Okay, so now we're going to do a slightly trickier example of running the CYK algorithm. We've got this new grammar here in CNF form, and we want to check if these two strings are in the language or not. So let's look at this string. So we'll set up our table as we did before. So first we write all the non-terminals that can directly produce 1. It looks like only B can do it. I'm dropping the curly braces for brevity, but remember these are really sets. What can directly produce a 0? Well, it looks like A or C. So A, C in these places here. Okay, so now we move a layer up. What can produce a B on the left and a B on the right? It looks like only A. Move to the next. What can produce BA? B can. What can produce BC? S can. So we get B or C in this set here. Move on. What can produce AB? S. What can produce CB? Nothing. So we just get S. Moving on. What can produce BA? B can. What can produce BC? S can. So we get BS. Alright, now we get 4 combinations to check. AA can be produced by C. AC can be produced by C, but we've already written that one down. CA, nothing. CC, nothing. So we get just C by itself. So move up to the next row. And again, we move up the column, down the diagonal. So BB can be produced by A. BS, nothing. Check the next one. AA, C. AC, C again, but we already have C. So A or C. And we'll complete the next row in the same fashion. So hopefully you got that. So we'll compute the next row. I'll do the first one and then skip the rest. Can I get BA? Yes, from B. Moving down. Can I get AS? No. Moving down. AB or CB. AB can be produced by S, and nothing can produce CB. So we get B or S. Okay, moving on. BS, nothing. 4 combinations to check here. BB, A can do that. BS, nothing. SB, nothing. SS, nothing. So just an A by itself. And we'll skip the last one, for which you should have just gotten an S by itself. Almost done, 2 more rows to go. So BA, B, AS, nothing, AB, S, AS, nothing, CB, nothing, CS, nothing. Move down a column, move up, down the diagonal, up the column. BA, B, we already got B. BC, nothing. SA, nothing. SC, nothing. So we get BS. So we move on to the next one. BS, nothing. BS, nothing. BB, A. SS, nothing. SB, nothing. Move on. AC can be produced by C. AA can be produced by C. We've already got that. AC can be produced by C. We've already got that. And so that's it. So now in the very last row, we have to compute all up this column and all down this diagonal, all in one go. Well, as soon as we've discovered S, we can halt, really. BA can be produced by B. BC can be produced by S. And I may as well give up at this point because I know it's possible to produce an S. So I'm done. And because there's an S in the very top symbol, that means there is indeed a derivation for this whole string. So what's it look like when the CYK algorithm rejects something? It means S is not contained in this set here. So let's look at an example of that. So in this case now I'm looking at the string 1111. So repeat the same process as before. So what can directly produce a 1? Only B. So we just get B's by themselves. What can produce BB? A can. And by symmetry these are all the same. And move up to the next row. What can produce BA? B can, and only B. What can produce AB? S can, and only S. So we get S, B on this row, and then by symmetry we get the same again. And then we move up. What can produce BS? Nothing. What can produce BB? A can. What can produce AA? C can. What can produce SB? Nothing. What can produce BB? A can, but we've already got the A. So the algorithm terminates. The set X14 is A and C, of which S is not a member. That means this string here is not in the language of the grammar. So I recommend that you do these examples again yourself, so that way you've got a good handle of the CYK algorithm.